So for this video, we're going to talk about tangential acceleration and centripetal force. So first thing we're going to talk about is tangential acceleration, which is the rate of increase of orbital speed or tangential speed. And this will look like, say something is traveling in a circle around like this. This is what it'll look like. So if it's here, it's here, it's going this way. So the tangential acceleration is always the tangential speed is always speeding up, and the direction of these vectors is ever changing because its location on the circle is changing, and it's pointing ahead. Alternatively, centripetal force, which can be denoted as Fc, we have an equation for it, which is m times v squared over r. Centripetal acceleration would just be v squared over r, but the centripetal force is always towards the middle, and we can think about this force as let's just say in an amusement park ride, when everyone is spinning around, it's what keeps them in the same place spinning around, because this force going to the middle is counteracted by normal force, which keeps them in their same spot. So what we're going to do next is we're going to go straight to the example. So here it is, problem 31. So it's a two-part problem, but we're just doing the first part. So a particle of mass m moves counterclockwise around a horizontal circle of radius r, as shown above. The angular speed of the particle is given as a function of time t by omega t equals bt, where b is a positive constant and t equals 0. So they talk about angular speed here being constant, just remember that. And then, so what we're trying to find, which of the following best describes the acceleration vector of the particle at the moment shown in the diagram. So of course it's going counterclockwise around this, like this. So what we have to figure out is whether they're talking about tangential acceleration, the tangential acceleration vector, which would be like this, or the centripetal acceleration, which is straight towards the middle. So now let's look at our answer choices. Directed towards the left, directed towards the bottom of the page, which would be A would be tangential, B would be centripetal. Directed toward the top of the page, we know that's a no-no. D, towards the right and bottom. It could be, that couldn't be. And then we're gonna have E, which is towards the left and bottom of the page. So A, B, and E are all promising, and for this problem, the answer is going to be E, because of course there's always, if it's going in a circle, there's always this centripetal acceleration, which is v squared over r, and then there's going to be the tangential acceleration, and we know that this tangential acceleration exists because the angular speed. So what we have to realize is that it says that the angular speed is constant. So that means that the amount of revolutions per amount of time is going to remain the same. So to do that, the tangential acceleration is going to exist and not be a non-zero value. So in this instance, we're going to choose A, which is directed towards the left, because we want to choose the tangential acceleration rather than the centripetal acceleration, because the centripetal acceleration is less applicable when there's a constant angular speed, as you can see.